in the lecture on the notes that we're going to be looking at a probability model. Here's that table. All right. This is for the number of repair calls that an appliance repair shop may receive during 1 hour. I don't know what hour, so that would probably change it, right? Lunch hour, morning, evening. So your possible values for your random variable, which how do we want to label it? What letter do you want to use for the random variable? X. That sounds good. All right, so we'll use X. Okay. Could be 0 calls. They could get 1 call, 2 calls, 3 calls. But according to this model, will they get 4 calls? 5 calls? No, right? This is it, 0 through 3. So to find how many calls they expect, we're going to find it's in the word. We're going to find the expected value. Very good. We're going to find the mean. All right, so this is your choice. You don't have to do all of these. Mu or expected value. Remember, you choose. I'm going to write both, but you can just pick one. So 0 times 0.1 plus 1 times 0.3 plus 2 times 0.4 plus 3 times. So we take each of our possible values for this variable, 0, 1, 2, 3, and multiply them by their corresponding probabilities of occurrence. So you take your calculator and you find out what it is. All right, who got something? Thomas? No, just kidding. Do you need a calculator, Thomas? Yeah? 1.7? 1.7? 1.7. You good? Everything okay? All right. Let's put a unit. 1.7 calls is right. Now, every year I do this, all right? Some students look at that and they kind of go, what? Why do you think they might be a little confused? 0.7 calls. And some of my other students were like, what about a voicemail? Like, stop, okay? We're talking about actually talking to someone on the other end. So what I try to tell you with this example is it's okay to get something that isn't even possible, right? So I know this is weird to say, but the mean, the average is 1.7, even though it's probably going to be 2 or 1, right? Does that make sense? So it's okay if your number is not possible. That's fine. Everybody good on the mean? Questions on the mean? Okay, let's by hand find the standard deviation. Now, when you find the standard deviation by hand, what are you first going to find? The variance. All right, here's how we do it. All right, so I'm going to call this the variance of my random variable x. All right, so my first possible number of calls they could get is 0. Right, that's in my table. My first one is 0. So you take that 0 and you subtract the expected value or the mean, which is 1.7. Now, do you guys remember from earlier in this semester what we have to do whenever we do this difference here? Remember we have to do something up here? We have to square it. Do you know why we have to square this? That's right, but you know why we have to square it. You're right, but you know why we square it? Let me try this. What number is going to happen when I subtract 0 minus 1.7? A negative 1.7. What happens when I do 3 minus 1.7? Positive. And so if you start taking negatives and positives and start adding them together, right, they're going to cancel each other out. So to get around that, we square everything. All right? So that's why we have to find the variance first to find the standard deviation. But here's the new thing. That's not new. Here's the new thing. The new thing is we need to multiply by the probability. And what was the probability of 0 calls? 0.1. All right? So you just literally copy and paste, but we're going to change the numbers. So plus 1 minus 1.7 squared. I should have said write small, obviously. And when you're ready, you can take your calculator and start typing this in. I would say if I wrote parentheses up there, write parentheses in your calculator. All right, give it a shot, right? See if you can do it. Not working. Get around by hitting the little carrot above the division. Yeah. Catherine's got something. Nice, Catherine. Jonathan got the same thing, Catherine. Yeah, you can do that if you want, Estrella, but you can also do it all at once if you want. Your choice. Can I look and see? Hey, yours. It's got something different than I got. Can I not go over? Sad. Okay. It's close to what I got. I got 0.81. Diana. What? Okay. Make sure you put those parentheses, okay? Nice. Okay, he's almost done. Did Victor get it? Oh, syntax error. That's a shame. All right. So it's 0.81. Who's got units? Who's got units for us? No, it's not. Yeah, you're almost there. It's not calls, but it is calls, but it's not. Nope. Nice. What? No. What did we do to these differences? What did we do to the differences? We squared them. So the units is squared calls or calls squared. I like putting a little square there. The point I'm trying to make, I know that sounds silly. The point I'm trying to make is calls squared or squared calls, does that mean something to you? No. What means something to you? Well, maybe not. But what do I care about? Calls. So to get the standard deviation, we take the square roots. Too much math? Oh, that makes me so sad. This is like not much math at all. All right, so what's the square root of 0.81? It is 0.9. Very good. And this one is going to be calls. Okay, how are we feeling on standard deviation? I'll show you right now how to do all of that with your calculator. All right, so go ahead and put your pen or pencil down once you have that written down. Turn your calculator on. I'll turn mine on too. This is like literally the greatest thing I've done in the last 6 months was figure this out. All right, ready? Hit stat. We're going to edit. In list 1, let's put our possible values for the random variable. So 0, 1, 2, and 3. Second plus sign is second memory, and then you can reset. You can also, if you just want to clear out the stuff, you can scroll up to the L1 and L2 or whichever one and hit clear when it's highlighted and then enter, and it'll clear the whole list. Here, I'll show you right now. Well, you know, if you want to do it yourself. Okay, and then in list 2, let's put the corresponding probabilities that those would happen. So 0.1, 0.3, 0.4, and 0.2. All right, we have that in. All right, so now hit stat. but we're going to go over to calculate. So hit the arrow to the right where it says calc for calculate. We actually only have one variable, right? What is our variable? Calls, nice, right? I do this because that's what I do. I don't know what you guys do, right, with your phones, but like that's what we do. Yeah, I just call you, right? You're like, don't call me, text me. Okay, so hit one variable stats, so enter on number one. List one should be your list, but do you guys see where it says frequency list? This is something we've never used before, but now we are. The frequency list is those probabilities. So hit second, number two. Second, number two would be list two in frequency list. So what you're telling the calculator is, okay, take my numbers in list one and multiply them by list two. Hit calculate. Oh my goodness, what's the very first thing you see? That's the expected value, right? That's the mean. All right, and do you guys see sigma? Here's sigma. That is the standard deviation. Does it give you the variance? Do you see 0.81 anywhere? No. So how would you find the variance? Square the sigma. All right. Now, one note I want to show to you guys is that when I've been doing this, right, with our statistics, I've been telling you to use SX. Remember earlier in the semester I said SX? That doesn't go away. This is one of those opportunities, those exceptions, where you can use the sigma. Hopefully you'll see there is no SX, so you're good. You're not going to be confused. Okay? Everybody good? All right, let's go to number two. We've got the American Vet Association claims that the annual cost of medical care for dogs averages $100. So I'm going to use, for these random variables, I'm going to use D, and then I'll use C for cats. All right? So the expected value for D is $100. What is the expected value for the cat's cost? 120, nice. All right. It does give us the standard deviation for dogs, which is $30. And the standard deviation for cats is $35. You don't have to write that on the side. I just do that for my, purposes of reference. So letter A says, what is the expected difference in the cost of medical care for dogs and cats? So here we go, expected value. And what am I doing with my variables? I'm subtracting. It says difference. So I'm going to do dogs minus cats. Don't get bogged down in what I try to focus you on in the notes in the lecture. This is just straight up expected value. This is means. You can subtract means. There's nothing wrong with that. All right. So the expected value for dogs is 100. For cats is 120. What happens when you subtract that? You get negative 20. So we expect cats to cost more than dogs per year by $20 in terms of their vet costs. All right, that's hopefully not the part you get tripped up on. If they do this on the AP exam, if it says subtract, subtract. If it's means, if it's expected values. Here's where they're going to mess you up. What's the standard deviation of that difference? All right, so I'm going to find the standard deviation of that difference, but will I be doing subtraction? No. What will I be adding? What will I be adding? That word, that big bold thing somebody said. The variances. Nice. I'm going to be adding the variances. Okay? This is one of my, you guys joked about it earlier, one of my tattoos, right? Variances add. All right? So how do I find the variance for the dogs? What do I do with this? You square it. So it's going to be, I'll put it to the side here. Variances add. So 30 squared plus 35 squared. All right, let's see, what is that? $2,125, 2125. Confirm, 2125, 2125. Again, what's my units there? Dollars squared. So squared dollars. Wouldn't that be nice though if you could square your dollars? Right? Gosh. But that's not my answer, right? What is this right here? What is this square dollars? That's the variance. Nice, Victor. Well done. That is the variance. I don't want the variance, right? I don't want square dollars. So to find the standard deviation of the difference, I'm going to take the square root of 2,125. I think I heard somebody say 46.1. It's money, right? It's dollars. So let's do 10. Yeah. 09. What's after the 9? Got you. That was Raul. You're welcome. Just so you're famous. He plays baseball. I know this is the first time we're doing it. We're going to do it again on Monday. You'll have a quiz on it on Wednesday. Or when I say Monday, I mean like after break, so no worries. But that's the key takeaway here, and you'll see it when we review. That you'll see these types of problems where they're going to ask you for the difference, and you're just going to be in the zone of, oh, difference, subtract, and they'll get you. All right, we got to add the variances. All right. Any